our topic of discussion today is functions, specifically linear, parabolic, hyperbolic, and exponential functions. Now, I'll go through the questions depending on the type of question. We'll cover a bit of theory on how to answer that question and the different methods that can be used, as opposed to how we usually start the session, whereby we go through theory first. So I'll be doing theory while we are attempting the questions. So let us start. So our first question is from a June question paper. We've got question 6. Now, question 6 is a parabolic function. The reason that we know it's a parabolic function is because of its shape. It looks like a sad face or a smiley face. That's the characteristic of a parabolic function. Now, in addition to that, another reason that we know it is a parabolic function is because it has the function f of x equals to, now you see that x squared, that x, and a constant. Now, a parabolic function doesn't always have to have an x or a constant. It can also be denoted as f of x equals ax squared. As long as there's an x squared in it, that's an indication that it is parabolic, okay? So I would recommend knowing how to identify the different types of functions. It is quite important. So let's start. We've got the sketch below represents the graph of f of x is equal to negative 2x squared plus bx plus c. Now, because it's negative 2x squared, that means a is less than 0. That is why it is a sad face. If it was a greater than 0, meaning that if it was positive 2x squared, it would have been a smiley face graph. In addition to that, we have where point D is the turning point of f. So that is important. We now have the coordinates of our turning point, which is denoted by point D. Okay. Now, the graph of f intersects the x-axis at P and Q respectively. So P and Q are now our x-intercepts. Something important to take note of an x-intercept is that it is the point where the graph cuts the x-axis. Therefore, y is equal to 0. So always remember that an x-axis is the point on a graph whereby the function cuts the x-axis, resulting in a y value of 0. And the y-intercept is where the graph cuts the y-axis, resulting in an x value of 0. That information is important because it will help you to calculate the x values of the x-intercept or the y values of the y-intercept. So this is our TP point. Okay, now our first question is question 6.1. Determine the values of B and C. So what are B and C? What do they represent? Now, if you go back to our first statement, the sketch below represents the graph of f of x. You can see that within that function, we have unknowns, B and C. That information was not given to us. So we now need to calculate what is the value of B and what is the value of C. Now, because we are dealing with a parabolic function, there are two methods that we can use to calculate the function or the equation of a function. So let us go through those two methods quickly, and then we can see which method's going to apply in order for us to answer this question. Now, the first method that we are going to have a look at is our turning point form, which is y equals a into x minus p squared plus q. Now, this is known as our turning point form of a parabolic function. Now, in order for us to use this form to calculate the equation of a function, we require two items. So we require a random coordinate and we require the turning point coordinates. If we have any random coordinate and a turning point coordinate, we will then be able to use this form in order to calculate the equation of our function. But there is one thing that's important to take note of with the requirements. If you are given the value of A, you do not need the random coordinate. So let's make that requirement number 2. So if we are given the value of A, we do not need the random coordinate. So you can go with option number 1. If you have a random coordinate and your turning point coordinates, you can use that to calculate for your equation. If you have A known and you have your turning point coordinates, you can then use that to calculate for your equation. So if you have A known, you do not need a random coordinate. When I say random coordinate, I'm referring to any coordinate or any point that is on the function that is not your turning point, okay? Now, something important, what does P and Q represent? Now, P will represent the X value of our turning point. And Q represents the Y value of your turning point. So let us go and see what do we have if it's possible for us to use this method. Now, if we look at the information we are given, you can see that we only have one coordinate on this particular function. And that is not a random coordinate, it is your turning point coordinate. So automatically you can see that the first option won't work because we do not have a random coordinate. Now, if you look at the second option that I gave you, which was A known and your turning point coordinate. If you look at your function that I've highlighted, f of x equals negative 2x squared plus bx plus c. You can see that the value of A is negative 2. Keep in mind that the value of A represents the coefficient of x squared. So we now have A. A is known. So we are going to use option 2 if we were to use this particular method. We would not be able to use option 1. Now, let us explore an alternative method. So the next method that we are going to use is to utilize the x-intercept form. So this is known as our x-intercept form because it makes use of x-intercepts. Now, a requirement of using this particular form is a random coordinate needs to be known. And you need to have the x values of your x-intercept. Okay. Now, there's also an alternative that you can take. So option 2, if A is known, you do not need your random coordinate. You only need the value of A and your x-intercepts. If there's more than one, okay. Now, what does x1 and x2 represent? So x1 represents the x value of your x-intercept and x2 represents the exact same thing. So if you have a look at our graph, P and Q could represent x1 and x2. But if you notice, we do not have the value of P and Q, because keep in mind, P and Q represent our x-intercepts. That information was already given to us, right? So because P and Q are not known, we cannot use the second method. We cannot use our x-intercept method. So the method we are going to make use of for this particular question is the first method, which is to use the turning point form. Now, how do we choose which method to use? You look at the information that you have and you look at what you need. If what you need matches the information you have, you can then use that particular method. So we are using method 1. Why? Because we have our value of A and we have our turning point. So we have both requirements in order to make use of this method. So let us go back to the question. Now, we've mentioned that we are going to make use of our first method in order to calculate for B and C. So let us do that. So method number 1, all we need in order to use method number 1 is our A value, which is known, and our turning point coordinates. So let's quickly go back and see what that information is. So we can see that our value of A, which is the coefficient of x squared, is -2. And we can see that our turning point coordinates are D, which is 1 and 8. So let us use that information to calculate. So we're going to write down our form, which is A into x minus P squared plus Q. Now, we have our coordinates of D, which is 1 and 8. So P is going to be 1. Q is going to be 8, because keep in mind I previously mentioned that P represents the X value of your turning point, whereas Q represents the Y value of your turning point. We also know that A is equal to -2. So let us now go and substitute that into our form. A is -2, X minus 1 squared plus 8. Keep in mind, if our value of P was -1, this is what we would have done. So if P is equal to -1, we would have had Y equals -2 into X minus -1 squared. So don't leave out the negative because the form already has a negative. Be very careful with that. If the value of P is -1, you'll substitute that value of -1, resulting in X plus 1. Okay, so be very careful with that. If you leave out the negative sign or if you substitute incorrectly, your equation is going to be wrong. Now, our next step, we are going to simplify. So because we have the squared outside of the bracket, it then means that we need to write this twice. Okay, now from here, what we are going to do is we're going to use our FOIL method to expand. So we're going to have x times x, x times -1, and that is going to give us x times x will be x squared, x times -1 will be -x. Next, we have -1 times x and -1 times -1. So -1 times x will give us -x. -1 times -1 will give us +1. And that is going to be +8 at the end. Now from here we can see that we have like terms in the middle, -x and -x. So let us simplify that. So -x and -x will be -2x plus 1 plus 8. From here we need to multiply that -2 from outside the bracket into the bracket. And when you multiply, remember you multiply sign, number, then variable. So this is going to be -2 times x squared will give us -2x squared. -2 times -2x, we'll say negative times negative, that'll give us positive. 2 times 2, that'll give us 4. And we repeat the x. Next, we have negative 2 times positive 1. That'll give us negative 2, and we bring down positive 8. Now, finally, we can simplify this into negative 2x squared plus 4x plus 6. So we've now found the equation of that particular parabolic function that we were given. So we can therefore conclude that our value of b is 4 and our value of c is 6. Because keep in mind, this represents A, this represents B, and this represents C. Okay, so we've now found our value of B and C, which is what this particular question wanted us to do. Now let's have a look at our next question. So next we have question 6.2. The graph of G represents F when F is translated 2 units left and 3 units up. So we now need to find the equation of this new function G, keeping in mind that the parabolic function we have on top, this represents F, not G. So this is F. We now need to find G. Now keep in mind that G represents F when F has been shifted 2 units to the left and 3 units up. So when a graph has been shifted, what do we focus on in order to move it that 2 units left and 3 units right? Now, what we focus on is an important point, which is our turning point. Now, always remember your turning point within a parabolic function is going to be used for a lot of things. For example, the x value of your turning point in a parabolic function represents the axis of symmetry. The y value of your turning point in a parabolic function will assist you in obtaining the range of that function. And when you shift, you focus on the turning point coordinates. We are going to shift the turning point coordinates 2 units left and 3 units up. That will produce our new function. So let's attempt that on the side. So we were told g of x is equal to f of x shifted 2 units right, 2 units right, or was it left? Just give me a moment to double check. It was 2 units left, not right. So 2 units left and 3 units up. Now, if we were to represent this as a function or as a drawing, let's say we have this coordinate point here. And this coordinate point was D, which has coordinates 1 and 8. So this is 1, this is 8. If we were to shift D 2 units to the left, so when we shift to the left, we are looking at horizontal motion. So we look at our x value. So if you shift from 1, you shift 2 units left. All you need to do is 1 minus 2. That is going to give you negative 1. So once we shift this 2 units to the left, we will then have a coordinate of negative 1 and 8. If we were then to shift 3 units up, so we're starting at 8, we add 3 to go up. That gives us 11. So our new point would then be on negative 1 and 11. So that's how we can shift a point. You can do it in stages. You can shift horizontally first, then vertically, or you can shift vertically, then horizontally. But the most important thing to take away from this is that P is your horizontal motion, which is left and right. And Q represents vertical motion, which is up or down. Okay. Now, let us try and do this within our function. So whenever we try to shift using a function, and this is specific to a parabolic function, we will use our turning point form. Okay, so let's attempt that. So we've previously found our function. Where is that? Okay, here it is. So we found our function over here. Now, what I'm going to use is my turning point form. So I'm not going to use my final function. I'm going to use the one that we substituted, which is this one. This represents my turning point form because I've got my value of A in there, I've got my value of P in there, and I've got my value of Q in there. This is my turning point form. Whenever you shift a parabolic function, it's easier to use the turning point form. So I'm going to copy this out. So it was y is equal to -2 into x minus 1 squared plus 8. And as you can see, the coordinates of our turning point are already in this form, 1 and 8. So if you do not have your turning point form, you can get your turning point form by using completing of squares. So you'll take your standard form. Our standard form is this function over here, or this representation. This is our standard form. So if you do not have your turning point form, you can use your standard form and complete squares to obtain a turning point form. I believe there is a question such as that a bit later on, so we'll have a look at it then. Now, we need to find g of x, keeping in mind that this represents f of x. Now, remember we previously stated that g of x is obtained by shifting f of x 2 units to the left. So what we are now going to do is we are going to shift this function. So where's our P and Q? Let's go back there quickly. So our P and Q, our P represents 1. Keep in mind that P is the X value of your turning point. Now, if we were to shift this 2 units to the left, we just subtract 2. That's giving us -1. So we are going to substitute this -1 in this position. Once we find Q, we'll substitute it in this position. So all we are now doing is basically replacing the f of x values, okay? Now, let us find Q. So we were told or given the value of Q as 8. Now, G is obtained by shifting F 3 units up. So all we do is we add 3, that gives us 11. So that is what we are now going to substitute. So in order for us to get G of x, in place of P and Q, we are going to substitute -1 and +11. So before I substitute, I'll actually write down the form using its alphabets or its variables. So this is our form, a into x minus p squared plus q. So if you find it easier to substitute into the variable form or into the form that has actual values in it, you can choose which is easier for you. So if you want to substitute into 1 or into 2, that is completely up to you. Do what you find is easier to do. So we know that a is still -2, We know that x is now -1. That p-value, which is our x value of our turning point, that is now -1. So let's substitute that -1. And we know that the new value of q is now 11. So we add 11. Now we can simplify this. So negative times negative will give us +1 squared plus 11. So this is our new equation of g of x. Now, let us simplify this equation so we can finish up the question. So we're going to do the exact same thing we previously did in order to simplify. We're going to use our FOIL method, expand and simplify. So if we multiply the brackets, that is then going to give us x squared plus 2x plus 1 and then plus 11 on the outside. If we multiply -2 inside, that is going to give us -2x squared minus 4x minus 2 plus 11. And we can then finally say that g of x is equal to -2x squared minus 4x plus 9. So this is our new function, which is g of x, that was obtained by shifting f of x 2 units to the left and 3 units up. Okay, so this is another question from a past June exam paper. So we have question 7. The graphs of k of x is equal to 2x squared plus 8x plus 3. So as we can see, a is greater than 0. That is why it has a smiley face shape. And p of x, which is equal to 2x minus 4. So k of x is a parabolic function and p of x is a linear function. How do we know that? We know that because k of x, the highest degree is 2, meaning that the highest exponent is 2. So because of that x squared, we then know that it is a parabolic function. And a linear function, the highest exponent you'll find is 1. Okay. Now, if we analyze the graph, you can see that D is going to be your turning point. And you can see these are your x-intercepts, but the values or the point names were not given. You can see that this is going to be your y-intercept. Now, from the graph, or rather from the equation k of x, you can see that your y-intercept is going to be 3, because if you were to substitute x into 2x squared plus 8x, you'd end up with y equals 3. So we have this value. This value is 3. Okay. Now, let us read our first question. We've got question 7.1.1. The coordinates of D, determine the coordinates of D, the turning point of K. So we need to find our turning point coordinates of K, which is the point D. Now, there's 3 methods that we can use to find turning point. So I'll list them and I'll explain them, and then we can decide which method is best for us to use. Our first method for calculating turning point is to use our turning point formula. So that is -b over 2a. Once you find this value of x, you can then substitute that value of x into the function, or let's call it k of x because we're dealing with k, to get the y value of your turning point. So that is the first method that you can use. Something important to take note of is that b represents the coefficient of x and a represents the coefficient of x squared. Now, another method that we can use, so this can be considered method 1. Another method that we can make use of is our midpoint. Now, something important to take note of is that when you are looking at x values only, this represents our turning point, and this represents our x-intercept. So we've got two of them. Now, the x value of your turning point is considered the midpoint of the x values of your x-intercepts. So if you were looking at horizontals, if you are looking at x values only, what that means is for you to go from this x-intercept on the left to the turning point is the same distance if you were to go from the turning point to the x-intercept on the right. Now, because of that, we then have the formula xtp is equal to x1 plus x2 all over 2. So that is our x part of our midpoint. So we can calculate the x value of our turning point by adding up the x-intercepts and dividing it by 2. Now, once we've found that x value, it's the exact same process again. We substitute that x value into the equation in order for us to find the y value of our turning point. Now, keep in mind that x1 and x2 just represent the x values of your x-intercept. Now, the third method that we can use, this method is more of there's no calculation involved. It's more of extracting values from a equation. So if you are given the form, if your function is already in the form y equals a into x minus p squared plus q. So if it's already in the turning point form, all you need to do is extract the values of p and q. That will give you your coordinates of your turning point. So how do we get the value of p? We take what is inside the bracket and equate it to 0. Therefore, x will be equal to p. An example of this, let's say we had the equation y equals a into x minus 3 squared plus q. Let's make that q a 5. Okay, so let's say we had this particular equation. Now straight away you can see that your value of p is 3, not negative 3. The reason being is that the negative comes from the formula, not from the value of p. So you can test it out. So you'll say x minus 3 equals to 0. All you do is you take what's inside of the bracket and equate it to 0. From there, you are then able to solve for x. So as you can see, our value of x, our value of p is 3, positive 3, not negative 3. Let's try the same thing with a positive value. That way you can see that you're always getting the opposite of what's inside the bracket. So let's make it plus 3. So that is then going to be x plus 3 equals 0, and x is therefore equal to negative 3. So you can see the difference. Whatever you have in front of that value of p, the sign is always going to be the opposite. And our y value of our turning point is just obtained from q. Q, you do not need to change the sign. Whatever the sign of Q is in the formula, you extract it with the sign. So for example, at the bottom here, our value of Q would have been 5. Here, it would have also been 5. If I change this to negative 5, this will also be negative 5. So all you do is you take the value as is. It's only the x value or the p value, whichever you want to remember it as, that you need to change the sign. Okay, now our turning point coordinate here would just be the value of p, then the value of q. So those are the three methods that we can make use of. Now, let's have a look if we can use method 3. So if you look at our equation that's given, we do not have an equation in the turning point form. Therefore, we cannot use method 3. You can if you want to. You'd have to complete squares and then transform it from a standard form into a turning point form, but that's time consuming and it's only 3 marks, so I wouldn't recommend doing that. If we look at method 2, we need our x-intercepts. And as you can see, the x-intercepts are not given. You can still use the method if you were to equate k of x to 0, solve for x, you would then have your x-intercepts. But that is once again quite time consuming, so I would not recommend that method for this particular question. Now, if we look at our first method, all we need to do is take our formula, substitute b, substitute a, then take that x value that's obtained and substitute it into k in order to get the y value. And if we look at our question, we have the value of a, which is 2. We have the value of b, which is 8. So we have everything that we need to use method 1. So that is the method that we are going to use. So let's have a look at that. So method 1, we've got our formula. Before we use our formula, let's write out our function. Our function is 2x squared plus, I believe it was 8x plus 3. We'll double check in a moment. Yes, it is 8x plus 3. Now that we have our function, let us identify our value of a, which is 2, and our value of b, which is 8. Now we can use our formula. XTP is equal to negative b over 2a. We can substitute our value of b, which is 8, our value of a, which is 2, and that'll therefore give us a value of negative 2. So our x value of our turning point is negative 2. If we were to substitute negative 2 into this function, so we'd have k of negative 2, that'll be 2 times negative 2 squared plus 8 times negative 2 plus 3. And if you put that into your calculator, you will then end up with a value of negative 5. We can therefore conclude that our turning point coordinates are negative 2 and negative 5. Let us see if they've named the turning point. Yes, they gave it a name D, so they've used D to represent the turning point. So you can say, therefore, D is negative 2 and negative 5. So that is how we would calculate our turning point coordinate using our turning point equation. Now, let's have a look at our next question. So we've got, for which value of x is k of x greater than or equal to 3? So this is more of an inequality question. So how we would answer this is we first need to understand what the question is asking us. So they've stated, for which values of x is k of x greater than or equal to 3? Now keep in mind, k of x represents y. So they want to know for which values of x will that produce y values greater than or equal to 3. Now, if you look at 3, let's look at the right hand side of our graph first. Keep in mind 3 can be both on the left and the right, okay? Because a parabolic function has 2 arms. But for now, let us solely look at the right. Now, from what value of x is y 3? As you can see, y is a y-intercept, not an x-intercept. 3 is a y-intercept. and a y-intercept has an x value of 0. So we can see that on the right-hand side, we are starting at x equals 0. So we need to identify, are we going to the right or are we going to the left of 0? So let's have a look. Our question was greater than 3, not less than 3. So if it's greater than 3, it means that our y values need to increase from 3. So if we look at the point 3, from point 3, as we move to the right and as we move to the left, where is the y values increasing or decreasing? So as you can see, the more we move to the right side, it increases, it goes up and up. Whereas as we move to the left side, it decreases, it goes down and down and down till point D. So we have now identified that we are going to move to the right. So all you need to do is draw an arrow. Drawing an arrow will help you to use or to identify which identity sign you are going to use if that's something that you struggle with. So how do you know whether you're supposed to use this or this sign? It's based on the arrow. So as you can see the direction of my arrow, I'm going to use that sign. So that's only the first part. We've not yet completed the question. That's only the right side. So our answer to the right side is going to be x greater than or equal to 0. So for all the values of x greater than or equal to 0, our function of k of x is going to be greater than or equal to 3, which means that as we go to the right-hand side of 0, meaning 0, 1, 2, 3, 4, 5 until infinity, all our values of y are going to be 3 and up, meaning 3, 4, 5 until positive infinity. So that is only the first part. We now need to identify the left-hand side. So let's draw our ruler, or let's take out our ruler and draw a horizontal line. So this is the other value that is equal to 3, the other y value. So we need to identify what's the x value that produces this y value of 3. So far we've only found one value, which is 0. We now need to find the second value. Now, what is that second value? In order for us to find that value, all we now need to do is equate our function k of x to 3, because keep in mind, we've stated when is k of x greater than or equal to 3 is another way of saying, or not another way, but more specifically, in order to find it, you can equate it to 3. So you can replace that inequality sign with an equal sign. That will help you find the critical values that you need to use. Because keep in mind, we've mentioned that we need to find where are these values greater than 3, on the left-hand side or the right-hand side of this particular x value. We've already done it with 0. So we now need to find when is it greater than or less than 3? Is it on the left side or the right side of this particular x value? We don't know what it is yet. So in order to find it, because we know that y is 3 at this point, we can substitute y as 3 into our equation to find that point. So let's do that quickly. So this is now question 7.1.2. So we have k of x equals 3. We now need to find what x values produce that k of x equals to 3. So that is then going to be 2x squared plus 8x plus 3 equals to 3. Keep in mind that this 2x squared plus 8x plus 3 is your function of k. Now from there, all we now need to do is simplify and solve for x. So if we bring the 3 on the right to the left-hand side, that's going to be minus 3 equals 0. From there, you can see positive 3, negative 3 cancels each other out. So you are then left with 2x squared plus 8x equals 0. From here, you see that you have a common factor of 2x. So you'll be left with x plus 4 within the bracket. So you can have 2x equals 0 or x plus 4 equals 0. We then have x equals 0 or x equals negative 4. So we already identified the x equals 0 part. What we need is that x equals negative 4 part. That's what we were looking for. So we now know that on the left-hand side of this particular function, that x value is negative 4. That will produce a y value of positive 3. So now we need to ask ourselves, is it going to be on the left or the right side of negative 4? So let's have a look at the right first. As we move to the right, is our y values becoming greater than 3 or less than 3? So as you can see, as you move from the right of negative 4, the function's going down until that turning point, which means the values are becoming lower than 3. So we are not going towards the right. Let's have a look at the left. So if we go to the left of negative 4, are our values of y becoming greater than or less than 3? So as you can see, as you move to the left of negative 4, your y values are becoming greater than 3. So all you need to do is look at the inequality sign. So that's how the arrow looks. So my inequality sign on the left is going to have that same direction. So let us write that out. So it's just going to be x less than or equal to negative 4. All you need to do is make your inequality sign match the arrow. That's the easiest way to not get confused by the inequality signs. And something that's very important, don't forget to put the equal to sign as well, because keep in mind they've mentioned k of x greater than or equal to 3. If they just said greater than 3, we would have left out the equal sign. So it's very important, okay? That equal sign means inclusive, meaning including that value. So let's go write these as our final answers. We're just going to have x less than or equal to negative 4 or x greater than or equal to 0. Now there's two ways that we can write this. I'll use both notations. So that's one using the inequality symbols. If you don't want to use the inequality symbols, you can always use the second notation. So from negative infinity to negative 4, union from 0 to positive infinity. Now keep in mind, whenever we're using equal to, we use square brackets. When we are not using equal to, meaning if we use greater than or if we use less than, we use rounded brackets. And infinity will always get rounded brackets. Infinity never gets squared brackets because we do not know what is the actual value of infinity. So you can use whichever notation you find easier. Now, let us proceed to our next question. So next we have question 7.1.3. So question 7.1.3, determine the minimum length of LM, where LM is parallel to the y-axis with points L on K and M on P respectively. So let's look at our graph so we can better understand what's going on. So we need to use or rather we need to determine the minimum length of Lm. So this is Lm. As you can see, Lm is a point on our function k, and it's a point on our function p. So whenever you are trying to determine the length of a vertical line that touches two functions, all you need to do is subtract the top function minus the bottom function, or the higher function minus the lower function. So if you want to find Lm, you are going to subtract k of x minus p of x. The reason that we do that is because all we are technically doing is subtracting the y values to get the change in y, meaning the length of m. I'll do an example with you. So if this is your line, let's say this is 10 and this is 4. If you want to find the length of this line, the vertical length, all you do is the top minus the bottom, and it gives you 6. So we now know that the length of this line is 6 units. So we're doing the exact same thing with this Lm. We are subtracting the top y value minus the bottom y value. Keep in mind that k of x is a y value. So all we are now doing is saying the top y value minus the bottom y value. So k of x minus p of x. Let's do that on the side. So this is question 7.1.3. So in order for us to find the length Lm, we're going to say k of x, which is the top function, minus p of x, which is the bottom function. Now, from there, what is our function of k of x? Let's sub that in. That's going to be 2x squared plus 8x plus 3 minus, now p of x is given as 2x minus 4. There's a subtraction sign before multiple terms, in this particular case before two terms. Always keep it in brackets, because technically that negative sign belongs to the 2x and it belongs to negative 4. We're going to multiply that negative sign into the bracket. So whenever you have a negative sign that precedes multiple terms, always put those terms in brackets, okay? Now, let us try to simplify this. So we're going to end up with 2x squared plus 8x plus 3. Negative times 2x is negative 2x, and negative times negative 4 is positive 4. From here, we can simplify this by adding up the like terms. So 8x plus, or rather 8x minus 2x is going to give us 6x, and 3 plus 4 is going to give us 7. So we now have the equation for the length Lm. If we were to substitute the x value into Lm, we would get the length Lm. But keep in mind, the question did not want the length Lm, they wanted the minimum length Lm. Length Lm and minimum length Lm are two different things. So in order to understand what is the minimum length Lm, we need to ask ourselves, what is minimum? So if you think back to when you first started with parabolic functions, there were two things that were discussed when dealing with the shapes of the function. So if you have a greater than 0, your turning point would be known as a minimum. And if you had a less than 0, your turning point would be known as the maximum. So based on that, if we want to find the minimum length Lm, keeping in mind that the equation of the length of Lm now represents a parabolic function. So if we want to find the minimum of Lm, all we need to do is find the turning point of Lm, because technically minimum represents turning point. So let us do that. So the turning point of Lm, so we'll say XTP equals negative b over 2a, whereby b is that 6 value, so it's going to be negative into 6 all over 2 times. Now a is positive 2. From here, we will end up with negative 3 over 2. So the x value of the turning point, or the x value of the minimum of Lm, is negative 3 over 2. Now, we need to find the y value, because keep in mind I previously mentioned that if you were to substitute the x value into this function Lm, you would get the length. So we've already found the x value. All we now need to do is substitute that x value into this function to get our y value. So keep in mind, the only reason that we found x by using our turning point is because the question stated the minimum length of Lm. If they stated maximum length, we would have done the same thing. But if they stated maximum, Lm would have been negative 2x most likely. So keep that in mind. Whenever they use the word minimum and maximum, always think about turning points. Now, once you put this into your calculator, you should get a value of 5 over 2. So we can then conclude that the minimum length of Lm is therefore equal to 5 over 2. And that is our answer. Okay. You can put units if you want to, so you could have said 5 over 2 units, that's also fine. Whichever, it's completely up to you. If you wanted to leave it as 5 over 2, that's also acceptable. So we've got question 7.1.4. Determine the average gradient between k of negative 2 and k of 3. So keep in mind, these represent y values. So we can take this as y1, and we can take that as y2. So we need to find the average gradient between those two y values. When x is negative 2, y is 3, and the y value is k of negative 2 and k of 3. So keep in mind our x1 value will be negative 2 and our x2 value will be 3. So we need to now find average gradient. So if we go to our graph, let's try and find negative 2 and 3. So our value of D, what is our value of D? Let's just have a look quickly. I think we calculated the turning point previously. It was negative 2 and negative 5. So we know that the point D is negative 2, right? And our value of x1 is negative 2. So we are now calculating from this point of D all the way until k equals, or rather x equals 3. So that should be around here. So we are calculating the average gradient between these 2 points. Keep in mind that a parabolic function does not have a constant gradient. The gradient continuously changes as the function curves, or as the function increases or decreases. So if you are asked to find the average gradient, technically you're finding the straight line, the gradient of the straight line between those 2 points. Okay, so let us now attempt question 7.1.4. So we have question 7.1.4. We need to find the average gradient. We know that the gradient formula is y2 minus y1 over x2 minus x1. Now, what are our x2, x1, y2, y1 values? Let's go back to our question. We denoted it there. So we're going to have y2 as k of 3. So this will be k of 3 minus our y1 value will be k of -2. And our x2 value is going to be 3 minus our x1 value, which is going to be -2. Now, from here, all we now need to do is find what is the value of k of 3. If you want to, you could have separately found k of 3 and k of -2 on the side of your paper and then substituted the y values. Keep in mind that k of 3 just represents the y value of the function k when x is equal to 3, and k of -2 represents the y value of the function k when x is equal to -2. So let us have a look at what is our function equation quickly. It's 2x squared plus 8x plus 3. So let us substitute that in. So all we are now going to do is sub 3 and sub -2. So let's start. K of 3 is going to be 2 into 3 squared plus 8 into 3 plus 3. That is the first, that is our first y of 2. That is k of 3. Minus now second y, which is y1. That's going to be k of -2. So that's going to be 2 into -2 squared plus 8. Just give me a second to slide this over so we can create more space. That is going to be 8 into -2 plus 3. So we're subtracting those values. This is k of 3 and this is k of -2. Now at the bottom we've got 3 minus -2, so negative plus, or rather negative times negative gives us positive. Now from here we can put all of this into our calculator. So 3 squared is going to give us 9. 9 times 2 is 18. 18 plus 8 times 3 is 8, 16, 24. So that's going to give us, let's see, that'll be 18 plus 24 plus 3 minus, that is going to give us 4 times 2, which will be 8. That'll give us 8 times -2, which will give us -16 plus 3. And that is over 3 plus 2. So that is going to give us 45 minus, this is supposed to be minus -5. That's going to be 45 plus 5 over 5, which will give me 50 over 5, and my average gradient is therefore 10. If you wanted to, I don't have a calculator with me, that's why I didn't do that, but if you wanted to, you could have straight away put this into your calculator and automatically arrived at 10. That way you could have skipped the 2 steps in between. Whichever works for you is completely fine. So all you now needed to do was find the average gradient between 2 points. Whenever you find the average gradient between 2 points, all you need to do is calculate the change in y over the change in x. So identify which is your x1 and y1, identify which is your y2 and your x2. Once you've identified those values, you can substitute them into the equation and simplify. Okay. Now, let us move on to the next question. So next we have question 7.1.5. Now question 7.1.5 states, determine the value of t such that the straight line y equals 2x plus t touches the graph of k of x equals 2x squared plus 8x plus 3 only once. Now, keep in mind if these functions are touching. So let's say we've got this function. Before we do that, let me just clear this up a bit. So let's say we have this function that is touching our function k only once. So this is our, let's call this our straight line, y equals 2x plus t, right? And it's touching k only once. Keep in mind, at the point where they touch, they're going to have the same x and the same y value, because in a sense they're intersecting one another. So at the point whereby the two functions touch, they have the same x value, the same y value, which then means that you can equate the two functions to one another. You can make them equal to one another because they have the same x and the same y value at that point. Now, if we go on to read the question, let's read it one more time. The value of t such that the straight line touches the graph once. In order for this straight line to only touch the graph one time, the discriminant needs to be 0, meaning that it only needs to have one root. So if we were to move this function too high, if our value of t is too high, that means that this graph or the straight line is going to cut t twice. If we continue to move it too high, it's going to continuously cut our function k twice. And if we move it too low, meaning our value of t is too low, it's not going to cut the function at all. So our value of t needs to be such that it's not too high, whereby it's cutting the function multiple times, and it's not too low, whereby it's not going to cut the function. It needs to be positioned between an area whereby it is only cutting the function once. If it cuts the function once, the discriminant must be equal to 0. Always keep that in mind. So there's two parts to answering this question. So let's do the first part, whereby we equate both functions so that we can find our new equation. So this is question 7.1.5. Keep in mind we are equating k of x to 2x plus t. The reason that we are equating the two functions is because they are intersecting one another. When two functions intersect, they have the same x and the same y value at that point. So our value, or our equation of k of x, is 2x squared plus 8x plus 3 equals to 2x plus t. From here, we're going to take everything from the right and move it over to the left so that we can simplify the function. So it's going to become minus 2x minus t equals 0. From here, we can add up our like terms, giving us 2x squared plus 6x plus 3 minus t equals to 0. Now keep in mind our value of a is 2, our value of b is 6, and our value of c is positive 3 minus t. That's the constant. Okay, now remember what I previously said. In order for our functions to touch once, the discriminant needs to be equal to 0. Now, our discriminant, if you think back to last year, you dealt with discriminants. That was the part under the quadratic formula. So your discriminant is equal to bx squared minus 4ac. So that is our discriminant. Let us put that in. So we have our discriminant is equal to b squared minus 4ac. Let us substitute. B is 6, A is 2, and C, as we mentioned previously, is 3 minus t. So all we now need to do is simplify this, find our discriminant, equate it to 0, and then we can solve for t. Now, something important to take note of. The reason that we are using this discriminant, the reason that we are using this method is because we don't have the value of x. If we had the value of x at that particular point where they intersected, we would not need to use the discriminant method. But if you look at our equation, we've got two unknowns. We've got x unknown and we've got t unknown. If we knew what the value of x was, we would just substitute the value of x and then solve for t. But because we don't know what the value of x is, we need to get rid of it. The method of getting rid of x is to use your discriminant method. Your discriminant method removes x from the equation because you only deal with the coefficient of a, or rather the coefficient of x squared, the coefficient of x, and the constant. So keep that in mind, okay? Now, let us simplify this. This is going to be 36 minus 8 into 3 minus t. This will be 36 minus 24 plus 8t. And that will then give us 12 plus 8t. So this is our discriminant. Keep in mind what was said earlier. If it touches only once, the discriminant is then going to be equal to 0. So our discriminant is equal to 0. Therefore, we have 12 plus 8t equal to 0. From here, we can move 12 to the other side and solve for t, which will be minus 12 over 8. We know that 3, or rather 4, goes into 12 3 times. So you'll be left with minus 3, and 4 goes into 8 2 times. So your final answer is then going to be minus 3 over 2. So that is all we needed to do. We needed to find the value of t such that the equation, or the straight line, y equals 2x plus t will cut our function k only once. Okay, now let us move on to our last question of this particular exam paper, which is question 7.2. Now, question 7.2 states a quadratic function f has f of 1.5 equal to 0, f of -4 equal to 0, and f of 1 equal to -5. Draw a sketch of the graph f. Now, something important to take note of, because they've given you f of an x value equals to 0. That means that that is y equals to 0, which means that it is a x-intercept. Whenever your value of y is 0, that is an x-intercept. Always keep that in mind. In addition to that, they've also given you a random coordinate. That random coordinate is 1 and -5. So when x is 1, our value of y is -5. So let's try to sketch this graph. So we have 7.2. We were given f of 1.5. 1.5 can be written as 3 over 2. Doesn't always have to be written as 1 and 1 over 2. Is equal to 0. We had f of, I believe it was -4. Let us double check. Yeah, it is -4. So we have f of -4. And that is equal to 0 as well. In addition to that, we have the coordinate f of 1, which is equal to 5. Now, using that information, we now need to plot the graph. So let us draw our x and our y axis. Let us plot our points. So our first x value we were given was 1.5. So I'll plot 1. and I'll plot 2. The point 1.5 will be in between those 2 points. Next we have -4, so that'll be around here. Then we've got 1, which is 5. I've already put the plot point 1, so that's fine. Let's deal with the y values. We have 1, 2, 3, 4, 5. Let us make this as 5. Let me just double check. I feel like that 5 was supposed to be negative. Yes, it is a -5. Okay, so -5 will be -1, 2, 3, 4, 5. It'll be here. Okay. Now, let us plot. So our first point we were given as 1 and -5, so that'll be about here. Our second point we were given -4 and 0, that'll be about here. And the point above that, which is 3/2, which is 1.5, that's here. So as you can see, the shape of this function is a greater than 0. Because you can see where the points align, we're going to have something like that. We wouldn't be able to make it a less than 0 because it wouldn't really work out. It means we won't take into consideration that 1 and -5. So automatically you see that you are dealing with a function that is a smiley face function. Now keep in mind we were not given our turning point of this particular function. So we're just going to, we'll plot what we have. So let us do this. Okay, so from here we'll draw arrows to indicate that the function is continuous. And then we connect the points. Okay, so my function is not that neat, but hopefully you get the idea of it. All you need to do is draw your axis, plot the points that are given, and then identify whether you are dealing with an a greater than 0 or an a less than 0 function, and then plot those points. Okay, so that was our last question of that particular question 7. I believe the next question is a hyperbolic function and a parabolic function. So it's 11:30. I think we should be able to do at least 3/4 of the question. If we do not finish, then I'll just send the solutions in the group. Now, we have question 5. So question 5 states, the graph of g of x is equal to -2x squared plus 4x plus 16, and f of x is equal to 12 over x plus p plus q are drawn below. The point q is the turning point, and point D and E are the x-intercepts. So point Q is the turning point of the parabolic function, and point D and E are the x-intercepts of that parabolic function. Now, if you notice, there's some dotted lines that cut through point Q and point D. Those dotted lines represent the asymptotes of the hyperbolic function. So what that means is, because it's cutting Q, it means that the y asymptote of our hyperbolic function is equal to the y value of Q. And our x value of our vertical asymptote of our hyperbolic function is the x value of point D. So once we find the coordinates of Q and D, we will then have the asymptotes of our function, our hyperbolic function. Now, something important to note is that asymptotes are imaginary lines on a function or on a graph whereby the function itself does not touch those lines, meaning that at those imaginary lines, those dotted lines, the hyperbolic function does not exist. Now, you might be wondering, if the function doesn't exist on those lines, how is it that the parabolic function is touching those lines. Keep in mind that those asymptote lines are only for the hyperbolic function, not the parabolic function. So the parabolic function may exist on the asymptotes, but the hyperbolic function will never exist on those asymptotes. Okay. Now we've got question 5.1. Show that g can be represented by the equation g of x is equal to -2 into x minus 1 all squared plus q. So keep in mind that g represented our parabolic function, right? Now, we need to show that g can be represented by that equation. But if you look at the equation given in the top paragraph, it states that g is equal to -2x squared plus 4x plus 6. So how do we go from that standard form to our turning point form? Because you can see that the equation in 5.1 is your turning point equation. Now, I previously mentioned, I believe in the first question that we dealt with, that in order for you to go from your standard form to your turning point form, all you need to do is complete squares. So that is the method or the approach that we are going to use for this particular question. In order for us to move from our standard form to our turning point form, we are going to complete squares. So this is question 5.1. We have y equals -2x squared plus 4x plus 16. So this is the function we are now given. We now need to complete squares on this function so that we end up with -2 into x minus 1 all squared plus 18. Now, something important to take note of when you are dealing with completing of squares is that your coefficient of x squared must always be 1. If it's not 1, you need to factor out and get rid of it. It must always be 1, not -1, not 1.5, not 2. It must always be 1. So before we start, we need to get rid of that -2 such that our coefficient of x squared becomes 1. So if we factor out -2, we will then be left with x squared minus 2x minus 8. Now, as you can see, our coefficient of x squared within the bracket is 1. Now we can start to complete squares. So when we complete squares, all we need to do is that x squared will become x. We bring down the sign. So in this particular case, it's a minus sign. And then our coefficient of x, we divide it by 2. We're not dividing the coefficient of x by 2 because it is x. We're dividing it by 2 because that's what you always do. For example, if we had x squared minus 3x, we would have divided this -3 by 2, giving us x minus 3 over 2 in the bracket. So don't think that you're dividing by 2 because the coefficient is 2. You are dividing by 2 because that is what you always do. Always divide by 2. Okay, so 2 divided by 2 will give us 1 squared. From here, you subtract the last term within the bracket. And our last term within the bracket is -1. Therefore, we subtract that -1. Because the middle term, or because the sign within the bracket is minus, don't assume that is why we have minus the middle term. Whether it was positive or negative, you always subtract the middle term. So if we were dealing with x plus 1 all squared, we would have subtracted positive 1 squared. Okay. Now, from there, we bring down that -8. So I'll repeat the process once more. The first step is to get rid of the coefficient of x squared. If it's anything besides 1, you need to factor it out and get rid of it. You must only have 1 as your coefficient of x squared. From there, you bring down x and you divide the coefficient of x by 2, and then you subtract by the coefficient of x divided by 2. If we were to put this in a formula form, it would look like this. Okay. So this is what it would look like if you represented it as a formula. That's if the sign is negative. If the sign was positive, it would look like this. Okay, so let us continue. From here, all we now need to do is simplify what's within the squared bracket and then multiply -2 into that squared bracket. So let us do that. So from here, we have x minus 1 squared, and then we have -1 all squared becomes +1. So we bring down the negative, we bring down the answer to -1 all squared, and we bring down the 8. From here, we know that -1 and -8 becomes -9. From here, we can multiply this into the squared bracket. So we will therefore have -2 into x minus 1 squared plus 18. Please don't say -2 times x and -2 times -1. You cannot do that because the x minus 1 is locked. That 2 locks it. So you can't just go and randomly multiply into it, is because it's somewhat locked. Okay, that 2 means that you need to repeat the bracket twice, then you can multiply into it. But we are going to stop there because that is all we needed. We needed to complete squares to change the form of our standard form to our turning point form. And as you can see, it is in a turning point form. If we write our turning point form, it's a into x minus 1 squared plus q. Sorry, this is supposed to be p, not 1. So as you can see, our value of p is +1, our value of q is +18, and our value of a is -2. And yes, p is +1, not -1. Remember what we discussed earlier, that the value of p, which is the x value of your turning point, is always the opposite sign. Now, let us move on to the next question. So our next question, we have 5.2, hence or otherwise determine the coordinates of Q. Something that's important is the use of the word hence. Whenever the word hence is used, always take note that it's a continuation word, meaning that you are most likely going to use the information or the answer that was calculated in the previous question. So we are going to use the answer from question 5.1 to calculate question 5.2. So our question 5.2, we need to determine the coordinates of Q. Now keep in mind the coordinates of Q is the turning point of that parabolic function. Now, if you remember earlier when we discussed how do you find turning points, there were 3 methods that I gave you. We used the first method previously, whereby we calculated using our turning point formula. I believe we used that formula twice actually. Now, in this particular case, we are going to use the third method that I gave you. The reason being is that we have our turning point form. All we now need to do is extract the P and Q values in order for us to get our coordinate of Q, which is the turning point of our function G, which is our parabolic function. So this is 5.2. Let us extract. So keep in mind, P represents the X value of your turning point. and Q represents the Y value of your turning point. So we have the equation y is equal to minus 2 into x minus 1 squared plus 18. Now from here, if you extract what's in the bracket, x minus 1 equals 0. So always extract what's in the bracket, equate it to 0, and then solve. So this is going to be x equals 1. And we know that y is equal to the q value, which is 18. Therefore, we can conclude that our coordinates of q are 1 and 18. An alternative method that you could have used if you did not want to use this method would have been to go back to the original function that was given in the standard form. Let's just go and have a look at that function. So as you can see, the original function that was given in standard form was g of x equals negative 2x squared plus 4x plus 6. Now, if you wanted to use the first method whereby we used the turning point formula, that would have also been fine because they've stated or otherwise. Otherwise meaning you can use an alternative method. So hence meaning you use the method from the previous question. Otherwise meaning you can use any alternative method of your choice. So because we have the standard form equation, we can then take our value of a, which is negative 2, and our value of b, which is 4, and use the equation xtp equals minus b over 2a, and then substitute that value of x into the equation, the original equation, which is our equation of g, in order for us to obtain the y value. Okay, so let us move on to question 5.3. Now that we've calculated the turning point coordinates. Before we do that, let's just make a note of the coordinates up here so we can easily find them. One important thing, do you see that we've calculated the y value of our turning point? And we previously mentioned that the y value of our turning point represents the horizontal asymptote of our hyperbolic function. So this asymptote is now equal to 18. So it's y equals 18. That means that the value of q in your hyperbolic function is 18. So we now have a piece of our hyperbolic function. The only part of our hyperbolic function that we are missing is p. Once we find the x value of d, we will then have our complete hyperbolic function. So if we look at question 5.3, calculate the coordinates of D and E. So as you can see, D and E represent the x-intercepts of our parabolic function. When you are dealing with x-intercepts, always remember that the y values of those x-intercepts are 0. So let us calculate our x-intercepts for question 5.3. So we have question 5.3. G of x equals minus 2x squared plus, I believe it was 8x if I'm not mistaken. Let's double check. Oh, 8x was the previous function. It is 4x plus 16. So 4x plus 16. Now, from there, we know that we are calculating an x-intercept, which means y is equal to 0. Now, from here, we have, in place of y, which is g of x, we'll substitute 0 and then bring down our function. From here, you can move everything to the left, so that means the signs will change. And we can now divide both sides by 2 because we can see 2 is a common factor. So once you divide both sides by 2, you'll end up with x squared minus 2x minus 8. If you factorize this, you'll have x minus 4, x plus 2 equals 0. From here, you have x equals 4 or x equals minus 2. Now, because we have two values, we need to figure out and identify which x value represents which x-intercept. Because we were told calculate the coordinates of D and E. If we put the wrong x values, technically it is wrong. So if we look at point D is on the left side of the x-axis, meaning it's on the negative side of the x-axis. So point D is going to get the negative value, whereas point E is on the positive side of the x-axis, meaning that point E is going to get the positive x value. So let's start with point D. We've stated that point D is going to get the negative value. So that means point D is going to have the value -2 and 0. Keep in mind we use 0 because it is a y-intercept. And point E will get the positive value, which is 4. So we now have our coordinates of D and E. We can make a note of it here so that it's easier for us to see in case we need to use them. So we said D is -2 and 0. And E is 4 and 0. Now something important, remember we previously stated that the x value of D represents the x value of our, or rather the vertical asymptote. So this is now going to be -2. So we now have our equation of our parabolic function, because keep in mind that that -2 and that 18 represent the P and Q values. Because keep in mind the vertical asymptote is your value of P and the horizontal asymptote is your value of Q. So if we want to complete our function of f of x would be equal to 12 over x plus 2 plus 18. Now you might be wondering, how did I get x plus 2 when my value of p is -2? The reason is this is the form of your hyperbolic equation. I know the question used plus p, I just prefer to use minus p. You can use whichever you feel comfortable with. I just prefer to use this approach. Now if you were to substitute -p into this equation, you're going to end up with x plus 2. So that is how we ended up with 12 over x plus 2 plus 18. Now always remember that this p value represents your vertical asymptote, which is the x asymptote, and the q value represents your horizontal asymptote, which is your y asymptote. Okay, now the reason that x is a vertical asymptote is because it's the vertical line that cuts the x-axis, and the reason that y is a horizontal asymptote is because it's a horizontal line that only cuts the y-axis. Okay, so please don't get confused because we've said horizontal and vertical, and we normally associate y with vertical and x with horizontal. The reason is because a horizontal line cuts the y-axis, therefore horizontal is associated with, or therefore the horizontal asymptote is associated with y. And the vertical asymptote cuts the x-axis, therefore the vertical line is associated with x. So keep that in mind, that's important. Now, if we go to the next question, we have question 5.4. Determine the equations of the asymptotes of f and state the value of p and q. So we've already done that actually. So question 5.4, we need to determine the equation of the asymptotes of f. So I'll do that over here. Okay, it's full over there. Let's try and do it at the bottom here. So 5.4, we need to determine the equations of the asymptotes of f. Keep in mind the equations of the asymptotes is x equals p and y equals q. all we now need to do is go and substitute the values of P and Q into the equations, okay? So let us see, what is our value of P? We previously mentioned that P is -2 and Q is 18. So all we are now going to do is substitute -2 and 18 into P and Q respectively. That is our equations of our asymptotes. We get 1 mark per equation. Now the question is not complete. We need to state the values of P and Q. So we first needed to give the equations of the asymptotes, which we did. We then need to state the values of P and Q. So on the side, you can just put P equals -2 and Q equals 18. That's it. That is your 4 marks. Now, let's move over to question 5.5. Now, question 5.5, determine for which values of x will the graph of g be decreasing. Now, the graph of g is a parabolic function. So in order for you to understand increasing and decreasing functions, you need to first think back to your linear function. So let's start with question 5.5. Something quickly to take note of is that when a function is increasing, it means as x increases, the value of y also increases. So both x and y need to increase. And when a function is decreasing, it means that as x increases, y decreases. Okay, so an example, if this is our linear function, as you know, this is an m greater than 0 positive gradient linear function. Now, as you can see, as you move, let's put it in a different colors to not confuse us. So as we move to the right, meaning as x increases, you can see that the value of y also increases. So as you move to the right, the value of y must go up. This is known as an increasing function. And if you think about a negative gradient linear function, you can see that as you move to the right, as your value of x gets bigger, your value of y starts to get smaller. So as you move to the right, as x gets bigger, your value of y or the y values start to decrease. So this is known as a decreasing function. Now you can use these positive or negative linear functions in order to identify whether other types of functions are increasing or decreasing. So let us draw our hyperbolic function. We are dealing with a hyperbolic function that is a less than 0. It's a negative sad face hyperbolic function. So this is our function. And this is our turning point Q, which has coordinates 1 and 18. So on the sides of your hyperbolic function, your parabolic function, not hyperbolic function, we are dealing with G, which is a parabolic function, not hyperbolic, okay? So on the sides of your parabolic function, draw your linear function so that it matches the arms of your parabolic function. So as you can see, the arm on the left looks more like an increasing function, and the arm on the right looks more like a decreasing function. And if we go back to the question to try and identify which type we needed, let's have a look. Determine for which values of x the graph G will decrease. So we need to identify for what values of X will this graph be decreasing. So as you can see on the right of your turning point, the function is decreasing. So all you need to do is make an arrow moving to the right. And remember what we said earlier, that arrow indicates your inequality sign. Therefore, the values of X that will result in a decreasing Y value is X greater than 1. So as you can see, I've used the exact same symbol as my arrow. That's all you need to do. Draw your linear increasing and decreasing functions on either side of the turning point and identify which side, the left-hand side of the turning point or the right-hand side of the turning point, does it have an increasing or decreasing area. If it was a smiley face graph, if it was a greater than 0, it would be the opposite. So on the right, you'd have increasing, and on the left, you would have decreasing. Okay, so be careful with that. So our answer is therefore X greater than 1. Now, there's also a different notation that you can use to write X greater than 1. So let's attempt that. The secondary notation that you can use is X an element from 1 to positive infinity. That shows you're starting at 1 and going until the biggest positive value, which is positive infinity. Now keep in mind, we do not use square brackets because we are not stating equal to. We are only stating X greater than 1, meaning we are not including the value of 1. Okay. Now, our last question, or I believe our second last question, is 5.6. So let's have a look at question 5.6. Question 5.6 states, write down the range of G. So I previously mentioned, I believe in the first question that we attempted, that our turning point of our parabolic function is very important. I stated that the X value of your turning point of your parabolic function represents the axis of symmetry, and your Y value of the turning point of your parabolic function will assist you in obtaining the range. So for this particular question, question 5.6, we now need to determine the range of G, which is the range of our parabolic function. So I'll show you how to determine the range of a greater than 0 and a less than 0 parabolic function. So let's start with a greater than 0. So if this is our function, you know that your turning point is going to be the lowest point, the minimum, right? So let's call this P and Q. That's our turning point. Now, if you notice, this is your lowest point, right? And when you're dealing with range, you need to identify all the Y values that the graph touches. That is range. So in this particular case, you see that your range is going to start from your lowest point and go up, because this function is going up to positive Y infinity. So we can then say that our range is going to be Y greater than or equal to the Y value of your turning point. Another way of writing that is Y an element from the Y value of your turning point until positive infinity. So that is how you would calculate, or how you would determine the range of an a greater than 0 function. Now, if your function is a less than 0, as is the case with the one we are dealing with, you're going to do it slightly different. So if this is your turning point, TP, which has coordinates P and Q, your range is going to start from the highest point and go downwards, because your graph doesn't exist above the point TP. It only exists from TP going down to negative infinity. So you'd write your range as y less than or equal to the y value of your turning point. The alternative notation that you can use is y, an element from negative infinity to your highest point, which is ytp. Now, when you're using the secondary notation, the y an element, within your bracket, you must always have the lowest value on the left and the highest value on the right. So it's always from lowest to highest or smallest to biggest, okay? Now, we need to answer this question. What is the range of G? So the range of G is therefore going to be y less than or equal to 18, because our turning point, or more specifically our y value of our turning point, is 18. So the graph starts at y equals 18 and touches all the y values less than 18 all the way until negative infinity. So if we use the secondary notation, it's going to be y an element from our lowest value, which is negative infinity, to our highest value, which is 18. And that is the range of our parabolic function G. Now, let's move on to the last and final question of today's session, which is question 5.7. Now, question 5.7 states, write down the domain of G. If we want to find the domain of F, not G. So the domain of F, keep in mind that F is a hyperbolic function. So if we want to find the domain of a hyperbolic function, we can use this formula. X an element of real numbers where x is not equal to p, because keep in mind our function is going to touch every single value of x. A hyperbolic function touches every single value of x and every single value of y except the asymptotes. That is why we say x an element of real numbers, meaning all the x values except p, which is the asymptote. Now, our p value was -2, so we will conclude that our answer is x an element of real numbers where x is not equal to -2. If you want to find the range of f, it would be y an element of real numbers where y is not equal to q. In this particular case, our q value is 18. So it would be y an element of real numbers where y is not equal to 18.